Hi everyone. Today we are going to take a look at the molecular and empirical formulas as well as do a practice problem having to do with percent composition. Let's get to it. So the molecular formula, this is the standard formula that you see for any kind of compound. And what it is it's the number of each type of atom present in the compound. So let's take a look at glucose, for example. Glucose's molecular formula is C6H12O6. That simply means that there are 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen in one glucose molecule. So you're taking 6 carbons, 6 oxygens, and 12 hydrogens, putting them all together, and that forms one molecule of glucose. In contrast, the empirical formula is a ratio of atoms against one another in that compound. So let's take glucose again and let's reduce it. So what we come out with is CH2O. And if you can see why here, it's because there are 12 atoms of hydrogen and then 6 and 6 of both carbon and oxygen. That means that there's a 1 to 2 to 1 ratio of the atoms in a glucose molecule, meaning that carbon and oxygen are equal. So that's a 1 to 1 ratio. Anytime that you have two things that are nearly equal, that would be a 1 to 1 ratio. And then there's double the amount of hydrogen atoms, making it 1 to 2 to 2. And then we just write that like that. One carbon atom, and then 2 hydrogen atoms, and then 1 oxygen atom, of course relative. That's not the actual number. That's why we have the molecular formula up here. But the empirical formula is basically just the reduced form of the molecular formula. Now we'll go to something similar along the lines of empirical and molecular formulas. We'll move on to percent composition. And what that is it's the percent that a particular element contributes in relation to the total mass of the compound. What we're basically saying is that it's the percentage of carbon, oxygen, and hydrogen within that molecule that would make up 100%. So let's take a look at a practice problem. That may be the best way to do it. And our example is for glucose, and that's the molecular formula of glucose. Find the percent composition of oxygen. So we already have the empirical formula up here, so it's already reduced to this, right? We found that just a minute ago. What you're going to do is you're going to take the atomic masses, whichever one you're trying to find. We're trying to find oxygen. So we're going to take the atomic mass. Here, let's try this. Atomic mass of oxygen, whichever one you're trying to find. And then the sum of the atomic masses of the others. Actually of all of them. Some atomic masses. And so here's what that looks like for oxygen. The atomic mass of oxygen is approximately 16, right? So we have 16 grams over the sum of that entire glucose molecule. So we have 12 grams plus 2 grams plus 16 grams. And so we'll reduce that. 16 grams over obviously 14 grams plus 16. And we have 16 grams over 30 grams. And that comes out to equal about 53%. Let's write that a little bit neater. About 53%. We're just trying to figure out the relative mass of each atom within the compound. So what we're saying is that 53% of that molecule is going to be oxygen. And then we could find them for all of them just by switching places. We could find it for hydrogen or carbon, although we could find it for any of them just by switching the places. So the atomic mass of what you're trying to find divided by the sum of the entire molecule. Let's move on to a variation of the same question, basically. What is the empirical formula of a compound that contains 54.5% carbon, 9.15% hydrogen, and 36.3% oxygen? So lucky for us, notice how they didn't give us the total mass. Well, the good thing is that we don't need it. So we can make it anything we want. So we're going to assume mass is an easy number. Just because it doesn't matter. No matter what mass we pick, as long as the ratio and the percentages are right, you're going to get the same answer either way. So let's break this down a little bit. Let's start with carbon. Okay, so we're going to make it 100. Make it 100 grams here. And for the sake of the problem, if you added those up, you'll notice that they equal almost 100. So we can keep our same, we can just convert our percentages here to grams. We're going to take carbon, 54.5 grams over 12 grams per mole. And you know why we did that? Is because carbon has approximately 12 for a relative atomic mass. So that's why we're doing that, is we're dividing the number of grams that we pick, that we choose right here, and we're dividing that by the relative atomic mass. So, okay, remember our units will cancel here, grams and grams, and we're going to be left with 4.5 moles. Let's move down a little. We will move on to hydrogen. Hydrogen, we have 9.15 grams. We'll divide that by 1 gram per mole. And that is once again because hydrogen's relative atomic mass is 1. Cancel, cancel, and we have 9 moles. We'll go down to oxygen. We have 36.3 grams. Once again, I just want to reiterate that yes, that's the percentage in here in the question, but for the sake of what we're doing here, we can just convert them. We don't need to have the actual number of grams that we're using. We just need to make it easy and keep our ratios the same. That is the important thing, is keeping the ratios, keeping the percentages the same, because that's what we're trying to find. So 36.3 grams divided by 16 grams per mole. Once again, that is because the relative atomic mass of oxygen is 16. We divide those and we get 2.25 moles. And it's as easy as that. Now we're going to move on and find the empirical formula. So the empirical formula for this particular molecule, we can just think through this very easily. So looking at these numbers here, what makes it great about doing these problems is you generally have very easy numbers to work with. So here we have 4.5 moles, 9 moles, 2.25 moles. It's nice because one, we can estimate. This doesn't have to be exact. And the other nice thing is that we get small, easy to work with numbers. So let's take a look at this. We have 2.25 moles right here. Notice that that's about half of 4.5 moles. So we know that there's the ratio there is it takes, 4.5 divided by 2.25 is 2. So 2 carbons, right? 1 oxygen. And then let's look at the carbon to hydrogen ratio here. 4.5 into 9 is almost 2. So that's almost double there. So that means that there's 4 atoms of hydrogen. And this would be our empirical formula here. And we didn't even have to do any calculations to find that. All we had to do is find these numbers here and compare them. We had to compare them with one another. Makes very easy calculations in your head. And then we just need to find the ratios that they exist in. Thank you guys.